This is the first in a series of videos on the subject of statics, and today we are going to cover a very fundamental question, that is, how do you determine when a body is in static equilibrium. So we have a sample problem over here. This consists of an horizontal bar of a dimension 2 meters. There are three forces and one couple acting on it. There are two downwards forces. The first force, which we can call F1, is of 1000 newtons. Second force, F2, is of 500 newtons, and there's an upward force of 1500 newtons called F3. And there's a couple of 2500 Newton meter in the counterclockwise direction. So how can we say whether this body is in static equilibrium or not? Now there are two principles which govern when a body is in static equilibrium or not. The first principle says that sigma Fi is equal to 0. This basically means that the sum of all forces on the body should be equal to 0. And this is a vector sum as made appropriate by this bar on top. So this principle can be split into two sub-principles, that is 1a, sigma Fh is equal to 0. This basically says that the sum of all horizontal forces should be 0. And in this case, of course, you have to take the sign into account. But since we don't have any horizontal forces in our system right now, we don't need to bother about this. We will have to bother about it if there were any horizontal forces. And 1b says sigma F vertical is equal to 0. That is, sum of all vertical forces must be equal to 0. Now the second principle, which you need to test for only if the first principle is proved valid, is sigma Mi is equal to 0. That is, sum of all moments is equal to 0. Now sum of all moments is defined as sum of couples. For instance, this 2500 Newton meter, this will be counted in the couples, plus sum of moments of forces about any one point. Now carefully see what this any one point means. This means that we can decide, so to calculate the moment of a force, you have to decide a point on a body, and the moment is decided as the product of the force into the perpendicular distance between that force and the point. Now what we are saying over here is that this any one point can be any point on the body or even outside the body. So I can choose this point, 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 I can choose a point in the middle, I can choose a point here. But as soon as I've selected one point, that point has to be the same for all of these three forces. So this can actually help us in problem solving. If we choose the point cleverly, then you can actually reduce the number of calculations that you have to do. We'll just demonstrate how that works. So let's just shift this to the right a bit. So let's first take the first principle, that the sum of all horizontal forces should be equal to 0. We can see that there are no horizontal forces in this, so that is trivial. Sum of all horizontal forces equal to 0. And the next sub principle says sum of all vertical forces equal to 0. So F1 is a vertical force. F1 we can see is minus 1000 newtons. Sorry for that. F2 is equal to minus 500 newtons. These minus signs are because downward direction is negative. And finally F3, which is in the upward direction, is equal to plus 1500 newtons. So by a simple addition, we can see that F1 plus F2 plus F3 is equal to 0. So this principle is trivially valid since there are no horizontal forces, and this principle we have shown to be valid. Now since these two principles mean that this principle is held true, then we have to come to the second. If this was not held true, then we can simply say the body is not in static equilibrium. But since all of these are satisfied, then we come to the second principle, which says the sum of all moments should be equal to 0. So now the point that I'll take for calculating the moments of the forces is this point. So what is my motivation for taking this point? It's because this particular force passes through this point. Hence, the moment of this force about this point is 0. So this saves me this calculation. Now couple 1 is equal to 25 100 Newton meter. It's positive since clockwise is positive. Now let's calculate the couple caused by this force. The distance is 1 meter, and since this force is forcing it downwards, so this line of force rotates like this about this point. This is clockwise, hence is the negative couple of 500 into 1. So C2, if we can call it that, is equal to minus 500 Newton meter. Finally, C3, what you can see is 1000 newtons downwards. Again, about this point, it would force like this, which is clockwise. So C3 is minus clockwise 1000 into 2 meters, which is 2000 Newton meters. So again, we can see by simple calculation that C1 plus C2 plus C3 is equal to 0. So we have satisfied the principles of all the forces. This principle has been satisfied, and this principle has been satisfied. So since we've satisfied all of this, we can say that this body is in static equilibrium. Just take a moment to pause the video and solve the question given. Just enter your values in the boxes given so that we can evaluate this video lecture.